All right, so we are going to continue. This is 8.2, and we are going to simplify radical expressions. Okay, and the first part that we're going to do here, we're going to do fractional exponents. And we're going to be talking about, first let's recall one of our rules of exponents. Let's recall one of our rules of exponents. And let's see if you guys recall, we had x, and we said that this was equal to x r times s, right? Power to a power. So again, when we have r, this is equal to, so multiplying exponents is the same as raising a power to another power. Okay, so multiplying exponents is the same as raising a power to another power. It's exactly the same. So let me just give you an example. So if I have so if x to the third power is equal to 8, and they're asking us to find x. So we know that, let's just write it between parentheses. We know that x is equal to 2, right? So now we are going to power equal to 8, and we're going to finish add x to the first, x equals to 1. We're going to see how we got there. So this is what we have at the beginning. We're going to start x to the third power equals to 8. Right? Let me write it in blue. X to the third power equals to 8. Now, I know that 3 times 1/3 makes a what? Makes a 1. So if I have x to the third power and I multiply by the reciprocal because I want to make a 1, because this is the same, hold on, but this is the same as raising a power to another power. This is the same as raising a power to another power, right? So what we have here is x to the third power to 1/3, right? So this is going to be equal to what? To 8. And we're going to raise 8 to the same power. And we're going to finish right here. What is this? X to the 1 power. And what do we get on this side? But this is 2, right? So if we look at this part, 8 to 1/3 is the same as what? As 2. So how else is 2 related to 8? Let me write it down. Hold on. Here is my question. How else is 2 related to 8? And here's the answer. 2 is the same as the cubic root of 8. 8 is what? 1/3 to 1/3. This is equal to. So 2 is equal to the cubic root of 8 and equal to 8 to the exponent 1/3. So here comes the rule. Here's the rule. That means that the index, which is n, becomes what? The denominator of the exponent. All right? So that means the index, which is n, becomes what? The denominator of the exponent. All right? That's the rule. Now let's do these exercises. It says, so we gotta do that. The first one is the square root of 64. So the square root of 64 is 64 to what? To 1/2. That's equal to what? To 8. I rewrite it and I evaluate it. Number 2, cubic root of 64. So I'm going to do 64 to 1/3. And what's the cubic root of that? 4. Now, this part, they're asking me to rewrite using a radical sign. So they want me to rewrite it using a radical sign. So what do I do? What did I say that denominator is? It was the index, right? So here's the index, x to the what? To the third power. Remember, we said that that means that the index, n in this case, becomes the denominator of this exponent. Right here, that's what it happened. The index is the denominator. Okay, now let's try it. We're gonna evaluate in two ways. Let's do that. It's gonna have to be in a different. So we're gonna evaluate in two ways. So the first one, oh, that's number 4 exercise. 81. So we will rewrite using a radical sign, right? So we're doing number 4 here, but we're gonna evaluate this in two ways. So let's do it one way. This is one way to do it. So we're gonna have the fourth root of 81 to the third power, right? So what do we have there? That's going to be 81 times 81 times 81, which is 531,441. And when we get the fourth root of that, we get 27. But it's a long and big numbers. So wouldn't it be easier to find the fourth root and then cube? Yes, we can do that. Let me write it down. Wouldn't it be easier to find the fourth root and then cube? Yes, we can. And let's do it. Let me use a different color of this one. So it's going to be, this is what we have, right? So how about if we find the fourth root and then we cube? Then cube 27. That's much easier. Much nicer. So we can find the fourth root, and having that answer, we can cube that answer. So we could find the fourth root and then cube it. And here comes the rule. So the rule says that if we have x to the exponent r over s, this is equal to x r s is going to be the index, the denominator, and this is going to be equal to what? We're going to find this root and then we're going to use the exponent. And all of this is possible as long as square root, not a square root of s is a real number. Okay. So we need to verify this part first before we do anything. So let's do these exercises. So we have number 4. We did 4, so let's do 5. 5 says 1,000 to 1/3. Okay, hold on, there's my pencil right here. So this is going to be equal to what? Cubic root of 1,000. And what's the cubic root of 1,000? 10. There we go. Now, let's do 6. 6 is 1/9 to what? To 3/2. So this is equal to what? A square root of 1/9. And what did we say? Applying the rule to the 3rd power. It's exactly what I have here. So what is this equal to? The square root of 1, 1. Square root of 9, square root of 9 is 3. And that's going to be to the 3rd power. So my answer is going to be 1/27. Now let's do number 7. We have all right, so then this outside the 4th root of what? Of 16 to the what? To the 3rd power. And what is the 4th root of 16? That's going to be 2 to the 3rd power. 2 to the 3rd power is 8, and we apply that sign. What's the opposite of 8? -8. All right, now let's do number 8. Number 8, we have -16 to 3/4. Look at the difference between these two. This negative doesn't apply to this, doesn't belong to 16, it's outside. Here is inside because it has the parentheses. That's how you know. So then what do we have here? We have to the 3rd power. And what happened? Not a real number. We can't do it. We can't have an even index. An even index cannot have a negative radicand. So we're going to write down not a real number. Okay? Now let's try to simplify it. Okay? Because this is not a real number. So -16 square root 4th root of -16 is not real. Okay? Now we're gonna try to simplify this one. So we have 8, 9. Y times y8 over 3. All right. So what do we have here? We have the same base, right? The base is the same, so I can add the exponents because I'm multiplying. So what do I have? This is going to be y. I have the same denominator, 8 plus 2 is 10. Right? So now I could write it, I could say, I could have this answer, or the denominator is going to be the index, and 10 is going to be the exponent. Okay? Now let's do the next one. We're just simplifying. So we have x 2 over 7 and x 9 over 7. So we have, this is equal to what? Remember, the same base. So I'm going to subtract the exponents. So what do I get? 2, I have the same denominator. I'm going to subtract the numerators. 2 minus 9 is negative 7. So this is equal to x to negative 1. And because we don't have negative exponents, we don't want to work with negative. So what do we do? What is x to equal to 1 over x? So we don't want to, just at the end, because we don't want to do that, we don't want to have the negative, so that's why we write down 1 over 5, over 1 over x. Now, let's do, I have a couple more exercises. 11. We have x to the 9, 4 over 9 times x, negative 2 over 9. Okay. So we have the same base. I'm multiplying, I have the same base, so I'm going to add the exponents. 4 over 9 plus negative 2 over 9. I have the same denominator. 4 minus 2 is 2. So again, that can be my answer, or denominator is the index. Remember, x to the second power. All right? Now, 12. 12 says square root of x, double check, yeah. So what we have is a square root of x, which is 1/2, right? To the 1/2, and this one is 1/3. So same base, I'm going to subtract the exponents. Right? In order to have the same exponent, the same denominator, which is going to be 6, I need to multiply this one by 3 and this one by 2. So this is going to be 3 and this is going to be 2. So what do I have now? 3 minus 2 is 1. So this is, denominator is the index. And that's gonna be my answer. Okay, guys? And I guess that's it for 8.2.